In this video, we're going to be looking at example 7 on page 221 of the Maths Handbook and Study Guide for grade 12. So the question reads, circles x squared plus y squared equals 5 and x minus 3 all squared plus y minus 6 all squared equals 20. They touch each other at point P. Determine the equation of their common tangent. So we're trying to find the equation of this tangent. So that's going to be in the form y equals mx plus c. So there's two things we need. We need the gradient of the tangent, and we're going to need the point of contact of P to substitute in order to solve for x, substitute in for x and y in order to solve for c. So first thing we're going to do is we're going to find the gradient of OC. Why? Because your radius is perpendicular to your tangent. So if we've got the gradient of OC, we have the gradient of our tangent. So we're going to start off with the gradient of OC is equal to the y value at C minus the y value at O, all over the x value at C minus the x value at O, or y2 minus y1 over x2 minus x1. So that's 6 minus 0, all over 3 minus 0, which is equal to 2. Remember, your circle center is 0, 0 for circle center O. So now we know the gradient of my tangent because the radius is perpendicular to the tangent and our properties are perpendicular lines. The gradient of the tangent is equal to minus 1 over 2. So now we need to find the point of contact, P. How do we do that? We know P is the point of intersection of line OC with circle center O and circle center C. So if I can find the equation of line OC, I can substitute that y value either in here or in here and solve for x. And once I've got x, I substitute back into either of the equations to solve for y. So we're going to find the equation of OC. We've actually already done it. The y-intercept, or our c value, we know is 0 because it passes through the origin. So the equation of OC is simply y equals 2x plus 0, or just y equals to 2x. Be careful not to use the gradient of your tangent. This is the gradient of OC. So now we're simply going to substitute y equals 2x into the y value of circle center O. It is easier than substituting into circle center C. Even though we could use it, I'm going to use circle center O. So our circle is x squared plus y squared is equal to 5. So we're going to write this as x squared plus y squared, which we know is 2x. So 2x squared equals 5. Don't forget to square your 2 as well. That's x squared plus 4x squared, which equals 5x squared. And that equals 5. So therefore, x squared equals 1, and x is equal to plus or minus 1. But we can see that P is on the positive x side. So therefore, x is just equal to positive 1. X equals minus 1 is not applicable. Right, so now we have the x value at point P. So all we're going to do is substitute that x value of point P back into either the equation of circle center O, circle center C, or the equation of the straight line. Because we know that point P lies on all of those equations, it's easiest to substitute into the equation of the straight line. So if x equals 1, y is equal to 2 times 1, which is equal to 2. So now we know point P is the coordinate 1 and 2. And now we're just going to find the equation of the tangent. We know it's y equals mx plus c. The equation of the tangent was, or the gradient of the tangent we worked out earlier was minus a half. So it's minus a half x plus c. And now we're going to substitute point P. Always remember to tell the examiner what you're doing. So we're substituting in point 1, 2. And therefore we're going to have 2 is equal to minus 1 over 2 times 1 plus c. And therefore c is equal to 2 plus a half, which is 5 over 2. So the equation of the tangent is y equals minus a half x plus 5 over 2. There is an alternative method now that we can use to solve the problem. However, before we do that, I need to explain the concept to you. So let's say we have two circles. X squared plus y squared equals 10, and another circle, x minus 2 all squared plus y plus 1 all squared equals 5. Now, everything we've learned so far in graphs is if we want to find the points of intersection of two graphs, we make them equal to each other. However, with circles, it's a little bit different. So the first question here is, how would we actually make these graphs or these circles equal to each other? And that is, we would go x squared plus y squared, and we take the constant over, minus 10 equals 0. And over here, we would have x minus 2 all squared plus y plus 1 all squared minus 5 equals 0. So now that we have both equations equal to 0, we can equate them and make them equal to each other. So we're going to get x squared plus y squared minus 10 is equal to x minus 2 all squared plus y plus 1 all squared minus 5. Now we just have to multiply out. So we're going to get x squared plus y squared minus 10 is equal to x squared minus 4x plus 4, don't forget that middle term, plus y squared plus 2y plus 1 minus 5. So now all we have to do is add like terms. You'll see that your x squareds, your y squareds all cancel out, but what you're going to be left with is x and y. So if we simplify all of this, you should get 2y is equal to 4x minus 10, and therefore y is equal to 2x minus 5. So we haven't found the points of intersection of the circles. What we've actually done here is we found the point, the line that goes through the points of intersection for both circles. So the equation of this line here is y equals to 2x minus 5. And just as we did in the previous example, to find those actual points, we're going to sub y into the equation of one of the circles. We can do it into either circle. However, the circle centered at the origin, so the maths is much easier, and that's where we're going to substitute in. I'm going to do the calculations up here, so it's next to the equations of the circle in the pictures. So we're going to have x squared plus y squared, but now y is 2x minus 5, all squared equals to 10. So we're going to simplify. X squared plus 4x squared. Don't forget to multiply and times by 2 for your middle term. So that's minus 20x plus 25 equals 10. So now we bring everything over and simplify. We're going to have 5x squared minus 20x, and 25 minus 10 is 15. Now we divide everything by 5, so we're going to get x squared minus 4x plus 3 equals 0. And that factorizes to x minus 3, x minus 1 equals 0. So x is equal to 3, or x equals 1. And these are our x values of the point of intersection. So we've got 3 and 1. And then in order to solve for y, we can substitute into any of the equations, so either circle or the straight line, but it's easiest to substitute into the straight line. So if we put in x equals 3, 2 times 3 is 6, minus 5 is 1, or y equals 2 times 1, which is 2 minus 5, is minus 3. So my points of intersection would be x equals 3, y equals 1, or x equals 1, y equals minus 3. So now using this method, we can solve example 7 without actually solving for point P or the gradient of OC or the equation of OC, because if we make the circles equal to each other, we will get the equation of the common tangent straight away, because that is the line joining the two circles. So we can go x squared plus y squared equals to 5. And our other equation is x minus 3 all squared plus y minus 6 all squared equals 20. So now I need to equate the circles. I'm going to take the constants over to the left-hand side. X squared plus y squared minus 5 equals 0. And over here, x minus 3 all squared plus y minus 6 all squared minus 20 equals 0. And now because both circles are equal to 0, we can equate them. So now we're going to have x squared plus y squared minus 5 is equal to x minus 3 all squared plus y minus 6 all squared minus 20. And now it's just a simple matter of multiplying out. So we'll have x squared plus y squared minus 5 is equal to x squared minus 6x, don't forget that middle term, plus 9 plus y squared minus 12y plus 36 minus 20. And now all we have to do is add the like terms. So I've got an x squared on that side, which cancels out with the x squared on that side. Y squared cancels with y squared. So I can take my minus 12y over to the left-hand side, and we get minus 12y is equal to minus 6x, and then 9 plus 36 minus 20 plus 5 is equal to 30. And now I divide both sides by 12, so we get y is equal to minus a half x plus 30 divided by 12, which is 5 over 2. So straight away, without all the working, we can say the equation of the tangent is y equals minus a half x plus 5 over 2. Right, that brings us to the end of analytical geometry for grade 12. Now please remember, you don't learn maths by watching other people do maths. You learn maths by doing it yourself. So now it's your turn to go and do these exercises yourself. The Maths Handbook and Study Guide has exercises after each section and a mixed exercise at the end, which gives you your tough, hard, exam-type examples to practice. And if you really want to ace maths, go get yourself a copy of the book. It's available at all leading bookstores, online, and go through each chapter. Every section explains the examples through color coding and has exercises for you to practice at the end of the book.